going to be looking at this video is how to solve non-linear systems. In Algebra 1A, you solved linear systems, so we were solving, as an example, we might have had something that was like y equals 2x plus 3 and y equals 5 minus 2x, and when we solved this, we were looking for where those two equations touched. Well, we're going to be doing that same thing, but now we're going to have non-linear systems. So I'm just going to start with an example. We're going to have y equals x squared plus x minus 1 and y equals negative 2x plus 3. So what we're going to try to do with these two systems, it's called nonlinear because x squared is a quadratic, not a linear. We would just like to find where do these two equations touch each other. So the first thing that we're going to do is go into Desmos and graph them. So let me see if I can get there. Oh, this is going to work so well here. So we are going to go to, maybe, right, we're going to have y equals x squared plus x minus 1. That will be our first equation. And then the second equation was y equals negative 2x plus 3. Okay, so you'll notice we have two equations, and let me just move this down a little bit so we can see. We're looking for where do these two equations touch each other, and we could look at it by graphing for sure, but we're going to try to do this without graphing. So the first thing that I'm going to do, let me just go back to my PowerPoint presentation here. Okay, so we have this. What we're going to do, I'm first of all just going to draw a picture. Ooh, I gotta find my ink color again. Just a second here. Okay, so we're going to graph what that looked like. It looks something like this. Something like that. So what we're trying to find out is where do these two equations touch, like what comma what and what comma what. All right, the way that we're going to do this, very similar to how you did solved linear systems, these both say y equals, so we're actually going to use substitution. So since we know what y equals, we are going to put this up in for that y. So we're putting that in its place. So we're going to have negative 2x plus 3 is equal to x squared plus x minus 1. And now we're going to try to solve this equation. With any equation that has a quadratic in it, we want to set the equation equal to 0. So I'm setting this equal to 0. I'm actually going to make this left side equal to 0. So to get rid of the negative 2x, I'm going to do plus 2x. And then to get rid of the plus 3, I'm going to do minus 3. And so on this side I now have 0. On this side I have x squared. If I combine like terms, x plus 2x will be 3x, and then minus 1 minus 3 will be minus 4. Okay, and then from here we are simply just going to try to, we could use quadratic formula, but I'm actually going to factor on this one because I notice it's factorable, and most of these will be. I'll be looking for a negative 4, and I know that a positive 4 times a negative 1 will do the trick for this one, right? And then using the zero product property, we're going to get x equals negative 4 and x equals 1. And notice so we found the x coordinates of each of those points of intersection. Now we need to find the y coordinates. So what we're going to do, for each of these, we're going to have two different answers. We're going to take each of these numbers and put them in for the x in that equation. So we're going to have y equals negative 2 times negative 4 plus 3. That will give me 8 plus 3, which is 11. And then if I plug 1 in, I'll have y equals negative 2 times 1. So I'll plug the 1 in there as well. 1 plus 3, that will give us y equals 1. So when x is negative 4, the y value was 11. And when x equaled 1, the y value was also 1. So we just found points of intersection of a non-linear system.